We're going to go over some inferential statistics, and we're going to keep it brief. There's value in understanding the application of this, and there's plenty of situations where it should be, um, especially when looking at different data sets and figuring out which ones need to be researched further and which ones are good enough standalone. What we're going to do in this video is a little less detailed how-to and a little more just kind of walking through what the process would look like. Now, if you are interested in using this, or if you feel it is appropriate to use this, and you would be qualified to evaluate that and expected to do so if it is appropriate given your skill sets and training to this point. Now, the data set that we're looking at here, and we'll have it posted for you at the Moodle site, just go ahead and select that spreadsheet. This is poverty statistics in within certain racial breakdowns, and the raw data is on data or table S2201. You could actually go back and look at this, re-download it if you wanted to. It is for 2015. I've done a good portion of the cleanup and get ready for the statistics. So the first evaluation really is to look at what type of variance is there. So if you recall the ANOVA, the analysis of variance, this is going to tell us if the data sets are consistent with each other, right? How much of a problem is there in comparing these data sets? And we'll look at that. So if we went to our data tab, data analysis, we could run an ANOVA, and just to kind of see that spread. This has been done already on this data set, and it looks like this, right, where certain portions are fairly straightforward with just the sum of each call or each category, right? And this is all in percentage of population. We discussed normalization already, so this has been normalized so that it is more comparable between different population sets. The key items here, really, depending on what you're going to do, and we're not going to get too crazy, but your variance, right, is if you're going to do some T statistics or Z statistics, our sample size is 52, so you're kind of in that gray area of whether you would go with T for the lower end value or Z for the higher end value. But your variance would give you some clues as to what you were going to do or which test you might look at. But even more so, here's our F critical to say, hey, if you go above this number, we're going to have some issues. And not only did we exceed that number, we went way over it by a huge factor. So this, by comparing the data sets, we're recognizing that there is a lot of difference. There's a statistically significant difference, and that's very important to recognize the definition, a statistically significant difference. We have a null hypothesis, so it says all of these are the same, right? These are the same. And if you find that F critical here is greater or is less than your actual F statistic, then you have to reject that and say, well, at least one of them is different. So another statistical evaluation would be to use correlation. Right? There's, again, we could use Z and T, but these are maybe a little simpler as far as quick. Here we have a matrix, which if we kind of highlight what this is, just a kind of a reminder, like this is 1 because it's comparing it to itself. This is 1 because it's comparing it to itself, right? And then all the way down the chain, these are all blank because they're represented somewhere else. So for example, Asian and white here is also measured here with Asian and white. All right, let's clean this up so we can talk a little better about it. Now, correlation is used to see if the data sets move together, if they are consistent. Now, the values you're expected to see are going to range from -1 to +1, and we see that where we see some negative values, we see some positive values, but they're all between -1 and +1. Positive values closer to 1, and let's use this. Here's a value that is very close to 1, right? 0.92, and that is a representation or a comparison of the Asian data set and the Native Hawaiian and Pacific Islander or other Pacific Islander. Now, the influences racially and culturally here would make a lot of sense, that there would be a lot of overlap between Asian and the Native Hawaiian and other Pacific Islander, especially if you look at it from a racial breakdown. So they would fit similar categories. I'm going to modify this table so it's a little easier to read. How's that? But this also means, since it's positive, is that the variables in one data set tend to be associated with variables or data in the other data set. So they're highly correlated, as they move in a certain direction, as the big ones move, or if we were to draw a line, right? Essentially, it would be as they get bigger in one data set, then they would also get bigger with the other data set, right? So we're finding this positive correlation. Now the opposite goes for negative, right? So we see a large, well, large perhaps seems like the wrong word here, but we're seeing this comparison of white and black, right? So if we were doing some cultural, ethnic, and economic studies, that especially regarding poverty, because remember this is about poverty, and specifically the data set is about food stamps, right? If you go back to the original data, we recognize that the opposite is true, right? That the negative values closer to -1 tend to have small values of one variable associated with large values of the other. So what we're actually seeing is this relationship. So, right, so we have a small value here associated with a large value here, right? So we're actually kind of flipping it. So you have almost an inverse relationship. So if we were doing some studies on poverty and we were trying to market education within a community, we may find that if education is our way out of poverty, right, let's make that our hypothesis, that we may want to find those communities where there is a contrast, right, where there's a contrast between a white population and a black population. Let's recall from uh, our studies or our lecture earlier that these are correlations. This is not causation, and especially when it comes to demographics and uh, racial breakdowns and socioeconomic assignments for those racial breakdowns, uh, we tend to get very nervous or uptight or really uncomfortable. Uptight might be the wrong word, but uncomfortable because socially that creates a lot of unrest. This is a correlation and not a causation. So it is really incumbent upon the researcher, especially you as the market researcher, to start seeking out causation, not just the correlation. But the correlation is a great point to start with and say, okay, well, this is something that's very important to research further, right? It's just kind of this hot spot. All right, one more thing, and that is this one here. That is our values close to 0. And we have one that is, this one here is really nice, it's really close to 0, meaning that the relationship between white poverty and Hispanic poverty is essentially unrelated. They're not correlated. The map kind of just, well, it doesn't look like a horseshoe. If we were to draw a line, this is it here, we would use a kind of a spotted, we're not really sure where it goes. All right, so for statistical tools, this link is available. It goes through all the different statistical tools available in the data analysis tool pack. I would encourage you to be critical of the data that you're using, and I would be really encourage you to leverage it when it's appropriate, not to shy away from it. Sometimes a quick web browser search or Google search will show, hey, this is how to use it, this is how to interpret it, and since you've already been exposed to it, it should come back fairly quickly. But this is a little more on the advanced side of market research from just a pure quantitative approach. And we'll talk about some of the limitations and enhancements for this when we get to our mapping exercises.